Hello and welcome to the OTB channel. The BIOS was developed in the 1970s and still lives on in many computers, if only in the form of the legacy support that the newer UEFI interfaces offer. There's now talk amongst manufacturers such as Intel that legacy support is going to be withdrawn. What does that mean in terms of how you manage your system and how you partition your drives? And does it really make that much of a difference? This is what I'm going to talk about after the intro. Hello and welcome back. So many of us are still using BIOS, or at least legacy BIOS support. And there are certainly some good reasons why people do this. The first one being you might have old hardware and it only supports BIOS, it won't support UEFI. You have no choice. The second reason, if you do have a UEFI interface of always going for legacy support, could simply be that the UEFI firmware is an early version and quite buggy, and so the legacy support gives you a more consistent and reliable experience. So both of those situations are entirely valid, and I understand why people do that. I'm guilty myself. I only switched over to UEFI 12 months ago, and the reason was, well, I suppose I'd cut my teeth on installing operating systems on computers that had a BIOS. I understood how it worked. I knew that the BIOS did the post, it then passed on control to the operating system via the master boot record that lived on the first 112 bytes of the active drive. And it all just worked. It wasn't problem-free, of course. We always had issues of MBRs becoming corrupted, or installing another operating system and having that MBR overwritten by the new operating system's MBR, Windows, I'm talking about you. But it was ultimately fixable, and we all knew how to fix it. We knew how to fix it in Windows, we knew how to fix it in Linux, and it was simple. I think that I was further persuaded not to move to UEFI simply because I understood the master boot record and how a BIOS worked at a basic level, not the technicalities, but at a basic level. And so legacy boot would always be the option that I chose, and I would force the operating system I was installing to boot in that mode. And I'm constantly surprised when I read forums and have chats on the internet of just how many people are still doing that. But with support likely to be withdrawn on newer machines over the coming years, we'll no longer have the choice. So what does that actually mean when it comes to managing your system and setting up the partitions? Well, the simple answer is probably nothing. Most operating systems install simply by going next. So there's no real reason to know all the underlying bits and pieces of what a UEFI installation actually means. The thing is, and you'll have seen this yourself in some of my demos, that automatic option using the likes of Calamaris doesn't always work. And then your only option is to create your partitions and mount them manually. For those of us who've been using Linux for quite a long time, before there was that automatic option, it's become second nature on where and what type of partitions to create and mount. But I was struck by a comment after one of my videos when Calamaris did crash, where the person says, how would I have known where to mount that ESP partition? So I thought it might be worth doing a quick video just looking at some of the advantages of UEFI over BIOS and some of the practical implications of how you change setting up your partitions, and does it really create that much work? So let's go through a few bullets and I'll expand on it as we go. So let's have a look at some of the advantages of UEFI compared to BIOS. The thing about having a BIOS and a BIOS formatted and partitioned disk was the fact that you were limited on the number of partitions that you could have. On an MBR disk, you could have no more than 4 primary partitions. Windows would only install on a primary partition, although Linux users were lucky because Linux was a little bit more flexible. And we used to exercise that flexibility by using a feature on an MBR disk that allowed us to create, yes, 4 partitions, but rather than having 4 primary partitions, we would have 3 primary partitions and then 1 extended partition. And an extended partition allowed us to have multiple, what were called logical partitions within it. So it was a little bit of a workaround. We could have 4 main partitions, but the extended partition was almost like a set of office drawers, 4 main drawers, but the 4th drawer would have lots of separate compartments inside. And Linux was more than happy to actually sit on one of those logical partitions. Well, that's all changed with UEFI because it's lifted that limit. No longer are we restricted to just having 4 primary partitions. Theoretically, you can create an unlimited number of partitions on UEFI. For practical purposes, Windows limits that amount to 128, but you're unlikely to actually go above that amount anyway. So the restriction is removed, and the whole concept of an extended partition with logical partitions underneath it is irrelevant as far as UEFI is concerned. So it's simplified the process. The second big thing is an MBR disk booted on a BIOS system was restricted to a maximum size of about 2.2 terabytes. Never used to matter. It was rare that you saw disks over 2 terabytes, but that's starting to change. And if you've got large disks, you're probably well advised to look at UEFI rather than a BIOS system, because UEFI theoretically supports 9.4 zettabytes. I have no idea how much that is. It's a lot. And it's not a restriction that any of us as desktop Linux users are likely to come up against, certainly over the next decade or so. I wouldn't have thought, but who knows. UEFI is also easier when you're managing a multi-boot system. With the BIOS and an MBR disk, you could certainly install multiple operating systems, but you were still reliant on that little bit of code in the master boot record, which would get overwritten each time you installed a new operating system. Now, for Linux users, it didn't matter that much because we use grub, and as long as we've got grub booting, you could normally pick the other operating systems up from it, because grub has the ability to chain load operating systems from other partitions. With UEFI, though, it doesn't look at a master boot record. It actually boots from a partition, or rather, it passes control of the system over to an EFI executable that lives on a partition. So the concept of overwriting an MBR doesn't really exist. And yes, when you install an operating system, it will generally set itself up as the first priority, and you may find that Windows takes over if you install that after Linux, or if you're doing multiple Linux distros, each new one you install sets itself up as the priority. But that priority is really easy to change. You simply need to go into the firmware interface. I was just thinking then, because we still call UEFI firmware BIOS for the most part. You can go into your UEFI firmware by hitting whatever, the F1, the delete key, or whatever it is on your system, and you can change the priority. On Linux, you also have a little utility that you can do it called EFI Boot Manager. So it's really simple. It's much easier than working with an MBR. UEFI also uses a different type of partition table known as a GPT partition table, rather than the old DOS partition table that we associate with master boot record disks and the old BIOS. If you only have a single partition, it's very easy for that to become corrupted. But UEFI creates a backup of your partition table anyway. So even if the first partition table right at the beginning of the disk gets scrambled or corrupted, you have a backup that can be used. There's also a much simplified boot process, which is, to be honest, meant to make the system so much faster. No longer does it have to go through all these stages of reading little bits of code on a master boot record and then handing over control to the bootloader. It simply looks at the ESP partition, or the EFI partition, EFI system partition. That's what ESP stands for. And it doesn't even need to use a bootloader. It can, in fact, boot your kernel directly. This is known as booting a stub kernel. So we no longer theoretically even have to go through the process of installing grub. You could, for instance, just use systemd's booting ability and boot a stub kernel straight from the UEFI firmware. So lots of advantages, really. The last one I've left right at the bottom of this list for a reason. Theoretically, UEFI is also more secure. And this is because of something called secure boot. Well, Linux has got a strange relationship with secure boot. Secure boot was designed to ensure that rogue code doesn't attack your system before the boot process. And potentially it can also stop an operating system being installed or booting. And for a long time, the way to install Linux on a UEFI system was always to ensure that we disable secure boot. It's become less and less of a problem recently with some of the big distros like Ubuntu, Fedora, OpenSUSE natively supporting the secure boot process, but it's not across the board as yet. And so I still tend to disable it by default. But eventually I'm pretty sure that most distros will support it. The disadvantages, as far as I'm concerned, are actually fewer than the advantages. The main one being that not all computers, especially older computers, support UEFI as yet. So you're pretty much stuck if that's the case. And if you've got one of the early implementations, I mean these ThinkPads that I love and I've talked about, the early implementation of UEFI on 2011 laptops was not the best. And so stability is often better if you use the legacy boot option. There's also an issue which doesn't affect us massively in Linux, but according to the UEFI standard, the bitness of the operating system, i.e. 32-bit or 64-bit, should match the bitness of the UEFI firmware. So if you have a 32-bit UEFI firmware, you should run a 32-bit operating system. If you have 64-bit UEFI firmware, which most modern computers do, you should only run a 64-bit operating system. In Linux, this standard is not hard and fast. We've long been able to run 32-bit systems on computers that have 64-bit firmware attached, so it's not so much of a problem, but theoretically, it could be. So that's pretty much it, really. Buggy implementations, older computers, yes, it's a problem, and there is this issue that we're really looking at 64-bit now. So what does this all mean in terms of the practicalities? And the practicalities are really the partitioning of the system right from the word go. Surprisingly, given the differences between BIOS and UEFI, the actual partitioning process doesn't actually change all of that much. In essence, it requires that we create an additional partition and we create a different partition table. So if you're using BIOS and you want to use an MBR disk, you would create a DOS partition table, as it's called in the likes of gparted. If you're using UEFI, you would create a GPT partition table. But other than that, the rest of the partitions that you create remain pretty much the same. You're going to have to create at least one partition for root. Optionally, you can create a swap partition, a separate one for home, USR, whatever your particular preferences are. I personally tend to create one partition for root, and these days I don't even create a swap partition. I just create a swap file at most on my installation itself. We have so much RAM available these days that a swap partition, whilst I still think we need some, is only massively important if you're going to hibernate your system. And I use SSDs, and hibernation isn't really recommended because you want to limit the number of writes. Although, again, that's becoming less of an issue. What you do need to do, though, on your UEFI GPT disk is you need to create, ideally at the start of the disk, one ESP partition. This is where the firmware is going to look to in order to boot your operating system. It has to be formatted in FAT12, FAT16, FAT32. Most of us choose FAT32. That's the way that we normally go. And there's a reason for that. It allows the firmware to use a standard file system irrespective of what operating systems are actually installed. So your UEFI system doesn't need to understand NTFS for Windows. It doesn't need to understand ext4 or Btrfs or whatever format you actually use. It only needs to be able to access a FAT file system to look for the EFI executable. The EFI executable, often grub still, can then read the information that it needs on the other file systems. But UEFI does not need to do that. We'll need to mount that ESP, and there are a couple of places that you can mount it. Favourites are boot or boot EFI. Now, your decision isn't just arbitrary. If you are going to boot your kernel directly from UEFI, it is advised that you mount the ESP partition on boot so that it has direct access to your kernels. If you would prefer not to have your kernels residing on a FAT32 partition, well, in that case, you can stick your EFI executable somewhere else. Personally, I mount mine on boot/EFI, which means that my kernels still reside on the ext4 partition in the boot directory. And only the small grub executable lives on the ESP partition. Now, this obviously raises implications for how big should your ESP partition be. And opinions vary. Microsoft tends to create a very small 100 and odd megabyte ESP partition. But generally speaking, in the Linux world, we're advised to create something of around 550, 600 megabytes. And it makes sense. If you have just 150 megabytes or something, well, it's probably enough if you're just mounting your system on boot EFI and you're not storing your kernels on it. But if you're actually mounting the ESP to boot and you have multiple operating systems, you want to make sure that you have enough room for all the kernels to be stored there. I tend to create 500 to 600 megs as a matter of course, but 550 megabytes is what is generally advised. Just one more thing. I often get asked, is it possible to have more than one ESP partition on a disk? And again, the short answer is yes. There is no theoretical limit to how many ESPs you have on a disk. But if you have more than one, I believe it can confuse Windows. There often isn't a need, though, to have more than one ESP partition because you can share that single partition amongst a whole range of different operating systems. And that's the case even if you're dual booting with Windows. So in essence, that's essentially all you need to know. The practical implications are actually quite few. You create a GPT partition table rather than an MBR partition table or a DOS partition table. You create an ESP FAT32 partition of at least 550 megs and you mount it on boot or boot EFI and you give it 550 megs. Simple. Now, there are some questions which I'm not going to go into detail here, such as, well, can I use a GPT disk with a traditional BIOS system, and can I use an MBR disk with a UEFI system? Well, the short answer is, yeah, you can if you have a real need to do so, but GPT and UEFI are so interlinked that it's often better to just stick with the standard. And Microsoft Windows, if you have a UEFI system and you're installing Windows in UEFI mode, will only install on a GPT disk. Linux is, once again, a little bit more flexible. Just one last thing to remember. I often, if I'm installing a new operating system, will wipe the disk. And the way I have done that on the old MBR disks was to simply use DD to zap the master boot record, the first 512 bytes of the disk. You didn't need to touch the partitions because the operating system then couldn't see any partitions because the partition table had gone. And it was a useful way of getting back to a raw disk and starting from scratch. You can't just do that on a UEFI GPT disk because there's a backup of the partition table, usually saved at the end. So you just have to use different tools such as gdisk or wipefs, which get rid of all of the signatures on the disk. What else? Well, that's pretty much it, to be honest. It's simple, and if you are setting up a system from scratch and your system is UEFI capable, there's no real reason to stick with legacy mode. And by the sound of things, you're soon not going to have the option. So people, hope that was helpful. Don't forget, you can join me on LBRY or on my OldTechBloke Facebook group. But other than that, I'll see you later in the week. Have a great day.